Okay, this is lesson 8.4, and this is a particularly important lesson because this is material that you will learn again in pre-calculus when you do trigonometry. This will be the basic material that you'll then expand on. So you want to learn it now so that you don't have to start from scratch in 2 years when you're in pre-calculus, that you can just be reminded of how it works and then you can go from there. So first of all, the term angle of elevation. If you take physics, you might also have heard this term, or you might hear this term. Angle of elevation is the angle formed between a horizontal line, and an observer's line of sight to an object above the observer. Okay, it's between the horizontal and the observer's line of sight. So if you were to look at this guy who's sitting on his bed here, he is doing what? Well, if you injure your foot, your ankle, your doctor might tell you to elevate your leg. So that's called an angle of elevation. So from the horizontal raised up is called the angle of elevation. Okay, so as a plane takes off, if you consider the horizontal to be either the ground and then raising up to where the plane is taking off, or it can be a segment parallel to the ground with the angle that the plane is rising as it's taking off. This right here is called the angle of elevation. Okay, so it's measured from the horizontal up. Now, the angle of depression. The angle of depression is an angle that is formed between again, horizontal line, between the horizontal and an observer's line of sight to an object below the observer. Okay, the word depression means to lower or to go down. So angle of depression means you're going from the horizontal down. Now, if you were to consider this situation here, so let's say there's someone standing on a field looking up at someone in the stands, maybe they're in the press box or up high in the stands. The person who's on the field is looking up at the person in the stands with an angle of elevation of a certain amount. Okay, so that angle measure is the angle of elevation from horizontal looking up. The person who's up in the stands is from the horizontal looking down, seeing that person on the field at the same angle. So looking straight out, dropping his eyes or her eyes down to look at the person on the field. The person on the field is looking straight out horizontally and raises their eyes up to look at the person in the box or in the stands. And those are going to be the same. So the reason that those are the same is because the angles that are formed there are what kind of angles? Well, the angle of elevation, the angle of depression are the same because if parallel lines are cut by transversal, then what kind of angles are these? Well, here's your parallels. That's creating alternate interior angles that are congruent. If parallel lines are cut by transversal, then alternate interior angles are congruent. Okay, so we have a few examples here. So mark a 30-degree angle of elevation on the diagram. So on this picture, if you were to stand down here, look horizontal, raise your eyes up, you would be considering that angle right there to be the angle of elevation. Okay, so this is your angle of elevation. 50-degree angle of depression. Now, if you're looking through an angle of depression, that means that you're up somewhere high looking down at something that's lower than you. So it could be like a cat who's up in a tree, or it could be someone who's up in a building looking at someone on the ground. So you're up on a ladder looking down at somebody on the ground below you, whatever. Okay, so if it's an angle of depression, remember it has to be from the horizontal, always from the horizontal. That means that if you're up here looking down at somebody who's down here, your angle has to be measured from the horizontal. So we're going to look at the horizontal there, we're going to draw out, and then that would form one side of your angle, and then this is the other side of your angle. So this angle right here is the angle of depression. Now, it's super, super important that you understand again that the angle of depression of somebody from up high is going to be the same as the angle of elevation for the person who's down here on the ground. So those two angle measures should be the same. So if this is like 30 degrees here, a 30-degree angle of depression, this should be a 30-degree angle of elevation. Okay, they're alternate interior angles, and the lines are both, and it's measured from the horizontal, those are parallel lines. So the alternate interior angles have to be congruent. Now, what you have to watch out for, it is never, ever, ever going to be this angle up here that you're talking about when you are given an angle of depression. If I wanted to describe that angle, I'd have to talk about it being maybe it's like a ladder leaning against a building, and this is the angle formed between the ladder and the building. I can't say angle of depression because angle of depression would refer to this angle out here. Okay, why is this not an angle of depression? Because this is vertical, not horizontal. That's measured with the vertical and the observer's line of sight. So it'll never be on the inside of the triangle there up at the top. Okay, so angle of elevation or depression. Well, this is someone who's down low, looking out, raise their eyes up. This is an angle of elevation. Okay, how about the last one? So this is a person who is standing up like on a pier or a dock or something, looking down at something below, like in the water, for example, or maybe it's like a canyon or something. So they're looking straight out, drop their eyes to something below them, and that is an angle of depression. Okay, again, it is not the angle inside of here. It is the angle that is actually on the outside of the triangle that would be congruent to the angle of elevation of someone who's down below looking up at the person in the top. Okay, so those are basic ideas for angle of elevation and depression. All right, now some examples. These are word problems, but don't freak out because they're not really difficult word problems in terms of how you normally think of like, oh, geez, word problems are so hard. You basically have to just figure out how to draw a picture, and then you use your picture to do trigonometry. So we're pretty good at doing trig from just generic right triangles. So the hard part of the problem here is to get the diagram drawn correctly. Okay, here's Jasmine. Okay, the angle of elevation of Jasmine to the top of a building is 49 degrees. Okay, so that means that the angle of elevation, this is going to be a right angle over here to make a right triangle. The angle of elevation from Jasmine to the top of the building, that means that over here is the building, is 49 degrees. If Jasmine is standing 400 feet from the base of the building, so if this is your building over here, that means that from the bottom of the building, like if she were to walk across to the building, it would be the distance that she would be walking. So that's 400 feet. And we want to know how tall is the building. That means we're looking for that distance, that vertical distance. Okay, so I'm going to highlight the stuff that I just drew on, that I just marked on the diagram. So we have 49 degrees. We have the 400 feet. Let me make this a little thicker here. We have the 400 feet, and then we have the x. So we're looking to use trigonometry. This is a right triangle. Okay, so we can say and let me remind you, sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so are we looking at sine, cosine, or tangent? Well, in relation to the 49-degree angle, across the triangle is your opposite, and then beside the angle is your adjacent. So that means we're using tangent. Okay, so the tangent of the angle, which is 49 degrees, is equal to the opposite, which is x, over the adjacent, which is 400. Okay, we have to solve that for x. So remember that means we're going to multiply both sides by 400. And then that's what we'd be typing in the calculator. So 400 tangent 49. Now, let's see what it said to round to. It says round the nearest foot. So it's 460.1 something or another. And that means that it's going to round off to 460. So x is approximately 460, and that would be in feet. Okay, next example. A 12.5 meter tall telephone pole casts an 18-meter long shadow. Find the angle of elevation to the sun. Make a sketch and solve and round to the nearest degree. Okay, so I'm going to draw the sun is up here in the sky, making shadows on the ground. So the telephone pole is 12.5 meters. This is your pole. And it's 12.5 meters. Oops. 12.5 meters. And then it says it's casting an 8-meter long shadow. Now, the shadow shows up on the ground. It doesn't hover from the top of the pole. Think about how a shadow works. When you have something that's brighter behind you and you make a shadow in front of you, the shadow's on the ground. It doesn't like hover from your head. Okay, so the shadow here, this is 18 meters on the ground. Let me finish off the triangle there. Okay, so it says find the angle of elevation to the sun. The angle of elevation to the sun means that you're standing down here looking up at the sun, and it's asking what's the angle that your eyes would pass through if you were looking horizontally and you lifted them up to look at the sun. What is the angle that's formed? Okay, so that angle of elevation is what we're looking for. It's this angle down here. Okay, so we're going to figure out what to do. Again, well, let's do sine, cosine, tangent. So, TOA. Okay, in relation to, in the triangle here, in relation to angle X, we have the 18 feet, we have the 12.5 feet. Okay, so in relation to angle X, we have the opposite across the triangle, then we have the adjacent, which is the leg that's beside the angle. The X here is in degrees. I'm going to put that on there just to make sure we remember we're finding an angle measure. Okay, X degrees. So are we going to do sine, cosine, or tangent? Well, again, we have opposite and adjacent, so we're going to do tangent. And so it would be the tangent of the angle, which is X degrees, is equal to the opposite, which is 12.5, divided by the adjacent, which is 18. Now, do you remember how to find an angle measure? You're trying to go from the answer, work backwards, and find the angle. So remember that means we're going to do inverse tangent. So we'll be typing in the calculator, inverse tangent of 12.5 over 18. Now, we don't want to do any rounding until we type it into the calculator. The very end will round. So don't be putting these numbers in the calculator and rounding off along the way. It makes your answer less accurate. So wait until the very end to do any rounding. The other thing I want to say is make sure that you're showing a diagram with some kind of labeling on it. It doesn't have to be a beautiful picture, but there should be some labels there, and then clearly showing the information that's given. We'd want to see a trig equation, and then we also want to see what you're going to type in the calculator, because if you do something incorrectly, we need to be able to figure out what you're doing incorrectly. Okay, so we've got inverse tangent of 12.5 divided by 18. Inverse tangent of 12.5 divided by 18. And then it said round the nearest degree. I'm getting about 34.78. So round to the nearest degree would be X is approximately 35 degrees. Okay, another little bit of practice with angle of depression or elevation, or neither. Okay, I want you to pause the video and try to do those 4 problems, and let's see how you do. Okay, so angle PQR. PQR. Well, is that an angle of elevation or an angle of depression, or neither? That is neither, because angle of elevation from Q would go horizontal up, horizontal up to something like that, or an angle of depression would be horizontal down to something down here. But when you're looking at angle PQR, PQR is that angle right there, and that is neither an angle of elevation or an angle of depression. That is neither. Okay, how about angle PRQ? PRQ is this angle right here. Now, remember that I mentioned to you that you're never going to be using that angle up there because it's from instead of being from the horizontal, it's from the vertical going down. Okay, so that is actually also neither. Okay, angle RPQ. Angle RPQ. RPQ is this angle right here. Okay, so we're going from the horizontal up on this one. Horizontal looking up. RPQ is an angle of elevation. Okay, and then SRP. SRP. SRP is this angle right here. And we're going from the horizontal down to create that angle. So that is an angle of depression. Hopefully you're good with those, because you have to know that terminology in order to be able to draw the diagrams accurately. All right, next example. The Gateway Arch in St. Louis is 190 meters tall. Okay, a boat in the Mississippi River is positioned 300 meters from the base of the arch. That means they're in the water. Okay, what is the angle of depression of an observer at the top of the arch to the boat in the river? All right, so I'm going to use a color here that we can see against the um, diagram. Here's the picture. There's our boat. Isn't that adorable? And then we're going to have a triangle that goes from an observer at the top of the arch looking down at the boat. Okay, and we're given that distance from the shore. Now, this is kind of at an angle. That's why it doesn't look like a right triangle, but we're kind of looking at it sort of from the side. So there's our right angle. It says that the Gateway Arch is 192 meters tall. So that means they've told us that, zoom in a little bit here. They've told us that this is 192 meters. They've told us that the boat is 300 meters from the base of the arch. That means this is 300 meters. And we're looking for the angle of depression. The angle of depression of an observer from the top of the arch down to a person, or down to the boat in the water. Okay, so here's the triangle that's drawn straight on to make it a little easier to see what's happening. Okay, so here's our right triangle. We have 192 meters over here. We have 300 meters over here. And it's asking you for the angle of depression. That means if the observer was standing up here in the arch, looking down at the boat, if they were looking straight out and then dropped their eyes to look down at the boat, it's the angle that would be formed right there. Okay, so I'm going to draw that over here. I'm going to extend this out because, again, an angle of depression has to be measured from the horizontal. And that's the angle that we're looking for. Now, again, we talked about how the angle of depression, angle of elevation are the same. So those alternate interior angles are the same, which means you can really just find the angle of elevation of someone who's in the boat looking up at the top of the arch. Okay, so what are we given? Well, we just labeled 300 meters, 192 meters, and then X. Again, I'm going to put degrees on there to make sure we remember we're finding an angle. Okay, sine, cosine, or tangent. Well, again, we have opposite, we have adjacent. You might notice that many of these problems will be tangent, but just make sure you don't fall into getting lulled into thinking it's always tangent, because it sometimes is not. All right, so we're doing the tangent of X is equal to the opposite, which is 192, divided by the adjacent, which is 300. Okay, then I want you to write what you're typing in the calculator. Inverse tangent of 192 over 300. That's what you'll be typing into the calculator. Okay, inverse tangent of 192 divided by 300. And that's going to give us about 32.6. Let's see, whoops. Okay, I am not able to switch to my pointer. I don't know what just happened. Okay, there we go. All right, inverse tangent, I forgot what the answer was now. Inverse tangent of 32.6. So it said round the nearest tenth of a degree, so that's what we want to say. X is approximately 32.6, and we want to label our answers. These are word problems, we always want to put a label on the answer. Not sure if I said that earlier, but make sure you're doing that. Okay, so again, we want to see a diagram that's labeled. Okay, we want to see the trig equation you're going to start with. We want to see what you're going to type in the calculator, and then we want to see your final answer rounded correctly with a label. Okay, rounded with the label, 32.6 degrees. All right, last problem. So I think you should pause the video and see if you can draw the diagram, and then we'll kind of check the diagram before we worry about actually solving it. So pause the video and try to draw the diagram. Okay, so there's a zip line in Las Vegas that is 800 feet long and starts at a height of 490 feet. So the person is up here getting ready to take the zip line. Like this. Okay, so the height is 490 feet. And the zip line is 800 feet long. That means as a person zips down, that's going to be 800 feet. What is the angle of depression of a rider who sees their friend at the bottom of the zip line? Okay, so again, angle of depression will go from the horizontal down. That's your angle of depression. That's the same as the angle of elevation from the inside of the triangle. So if your friend, this is the friend down here. Okay, this was the rider. I don't know if you really call that a rider, but the person who's doing the zip line. All right, and so we have the angle of depression is what we're looking for, and we have 490 feet here and 800 feet here. We're looking for X. So are we doing sine, cosine, or tangent? So again, I'm going to write this every time just to make sure I don't accidentally make a mistake on whether I use sine, cosine, or tangent. Okay, in relation to X degrees, I have the opposite. This time I don't have the adjacent leg, I have the hypotenuse. Again, we know this is the hypotenuse because it's across from the right angle. It's the longest side of the triangle. So which one uses opposite and hypotenuse? It's sine. So be careful, because you may be thinking that it's always tangent. It's not always tangent. off and off and off, and it is. Okay, so the sine of x degrees is equal to the opposite, 490, over the hypotenuse, which is 800. If you want to do something like divide out zeros, you could do that. You don't really have to, but you could do that. Okay, so what will we type in the calculator? We're going to type in inverse sine of, and again, you really could do 49 over 80. Okay, so 490 divided by 800, and we're doing the inverse sine of that angle. And running to the nearest tenth, 37.77 would become 37.8 degrees. Okay, that little squiggly that I'm doing there, that just means approximately, that just means that I rounded it. You always want to make sure you look at the amount to round to and then the label on your answer. Okay, that's the end of this lesson.